Hey everybody, welcome back. I'm Jason with Prometheus Lights, and today we're going to talk about how to spin a top. You would think it's easy. It's not super easy. It's definitely a skill game, especially if you want to get the maximum spin time. Now, I haven't really thought in advance about what I'm going to talk about, so hopefully I'll think of the right things. I guess the first thing to talk about is spin surface. There's some exotic stuff out there. What I use, what I think is the most reliable thing, is just a little shaving mirror. Pretty sure I have a link to Amazon to buy this exact mirror on my website on the top page if you want to check that out. This is a little 5-inch shaving mirror, I think about 12x. I have some smaller mirrors that are maybe 3 inches, and those also work pretty well. But I actually like to have a little bit of space to work with. I think, you find some really small spin stations and stuff like that, in particular lenses that people like to use. I would say for me, they tend to be too small in diameter, and they also have too much dish, which, I don't know, maybe it's just a preference thing, but I find I get the best results with this guy. It's important for your surface to be clean and free of debris, because as the top wanders around, if there are little bits of stuff on it, it's going to hit those and you'll see it kind of bounce around if it does hit one, which is kind of amusing, but it's going to cut down on your spin time. So the first thing to note about spinning the top itself is it's just going to take practice. You're going to have to do it a lot if you want the best spins. If you're just amusing yourself, then it doesn't matter. My kids enjoy playing with them, and they get a 15-second spin. It's just whatever you get enjoyment out of. I've spun, at this point, I'm sure, thousands of tops, and some days I'm on. I just nail it. I'm hoping today is one of those days. Some days I'm just off. I don't know, I find it's sort of like any kind of skill. Sometimes you're on, sometimes you're off. One thing I like about the larger diameter is I can kind of go a little bit crazier, and because there's more real estate for the top, it doesn't fly under the table. Oh, the other thing, broken contact balls. I have never personally broken a contact ball. I've dropped it on the concrete floor here many a time, never broken one. When people break balls, which is very rare, I think the problem is, as far as I've been able to deduce, because I always ask, well, how did it happen? People spin on granite countertops or tile, and both of those things are actually really, really hard, actually harder than steel in terms of the actual surface hardness. So when you do manage to drop a top onto that, or like a tile floor or something like that, there's a huge amount of force that's going into a tiny little point, and that can break the ball. I guess the other thing I should address is durability. So people are always like, well, how durable is the ruby? It's kind of hard to answer. If I just leave it there forever, it is infinitely durable. Nothing will ever happen to it. If you drop it 3 feet onto a tile floor, I can't say the same thing, but it's a ruby. Don't drop it 3 feet onto a tile floor would be my best advice. So you definitely, A, don't want to drop it. B, if you're worried about it, don't do it near granite or tile, because if you get a hard enough impact, it'll break. The other thing is, some people, when they spin their top, they like drop it. Don't recommend that either. Again, smashing. This is a precision instrument. This is glass. You might have a lens. Can we just agree not to drop it? It's probably just not the best, not a good best practice. Alright, I should have probably spun this thing when I first started talking, because that would have been more interesting. I'll do that next time. Let's spin it now. Yeah, okay, that was actually pretty good. So when you first spin the top, you're looking for a couple of different things. One is, right now, it's circling around, sort of orbiting, which is fine. That's what happens. You let it sit long enough, it's going to get stable. Now what you don't want to see in terms of wasting energy, and wasting energy equals shorter spin time. What you don't want to see is the top kind of going around at an angle where basically the angle of the spindle is going like this as it goes around. And I think really two things can cause that. One is releasing the top with the spindle not vertical. You're putting sort of twisting load on it. The other thing that can cause that is just insufficient speed. So if your top is not stabilizing, or it just goes in circles forever, which I guess is sort of the same thing, you're not spinning it fast enough. Because in terms of the physics, you need a certain amount of RPM for this configuration of geometry and mass for the physics to take effect that will actually cause the top to stand upright and perfectly still. So if you don't reach that speed, your top is not going to, what do they call it in the industry? I'm not up to with my nomenclature, I just kind of do my thing and figure it out. Oh, come on, what is it called? Resting? No, it's something else. Anyway, I'm sure somebody will be happy to comment and let me know what the term for this sort of steady state is that we have achieved here. This is the magic. I think this is what everyone is after. And so you have to have enough speed in terms of RPM. Even if you have kind of a wobbly release, if you get enough speed, it's going to wander around for longer and lose energy. But if you have enough speed, it will eventually stabilize because, again, that speed, because of the angular momentum, I won't get into all the details, but basically one side is falling and one side is rising, but that angular momentum makes the top want to be upright if you have enough speed. I don't know, what else is there? Oh, okay, so sometimes people write in and they're like, oh, my top's making this weird sound. And that is perfectly normal. If you have a good spin, you may or may not hear it. It's hard to say, but what causes, I don't know, it's kind of like a little buzzing vibration sound. I was just sort of channeling car talk and wondering if I'm going to try to make that sound on camera or not. And I guess now that I said it out loud, I guess I feel like I have to. Okay. Now I'm actually more embarrassed after talking about it. So it's kind of a sound, huh? You probably heard it before. Okay, so what causes that is because the top is orbiting in a circle, it is actually not making contact directly on the tip of the top. It's sort of a little bit around to the side, and the sound that you hear is actually the top skidding as opposed to spinning on the tip. It's skidding on the side of the ball as that's going around, and because, I mean, pretty much any contact point that you're going to use is very hard. There's a certain amount of friction involved, and that friction is part of what's making the sound. And again, if you're hearing sound, that is energy that is being lost. And if you spend a lot of time orbiting around, that is also energy that's being lost. In terms of personal record, I think my best spin is about 14.5 minutes, which I've only done one time. I have a few times gotten 12.5 minute spins. I have some customers that said they've gotten over 15 minutes with a solid brass top, which blows my mind, but apparently it's possible. People must have stronger spinning hands than I do. And again, I sort of go into this on the website, but I feel like without a ton of practice, you should be able to get 5 or 6 minutes. I think the next benchmark is 8 minutes and then 10 minutes. Even when I'm test spinning tops, for example, I will not always get an 8 or 10 minute spin. Definitely, I don't know, probably between 6 and 8 minutes. If I really nail it, you know, I might get a 10-minute spin on a test. But yeah, you just have to do it a lot. I guess the other question that people ask, does the contact point, whether it's ruby or silicon carbide, aluminum oxide, or stainless, those are the options that I have, does that make a big difference in the spin time? And I generally say no. And the reason for that is because the one variable that sort of has the largest potential impact and that is different every single time you spin it is how you spin the top. And so, you know, that's the combination of speed and angle and blah, blah, blah. There are a bunch of things that go into that. But that one, or that set of variables are impossible to control, and that's going to have a much larger impact on your spin time than what the contact point is made of. I do see some people that will do like basically statistical testing, and they have 2 tops, and you know, they spin it 20 times and write down the time for each one. And so maybe if you do that kind of thing, you might start to see a statistical trend where one thing performs better than the other. But unless you're like super hardcore and keep that kind of data, it's not going to make any difference. It's just sort of what you're into. I personally like the ruby, and that's why I made the original top a ruby. It's just sort of a machinist thing, and let me conveniently located. So these industrial rubies are normally used on expensive inspection equipment. So this is a work probe that I use on the mill, and I don't know if you're going to be able to see this or not, but it basically has a ruby ball on the tip. And so this will come in and, you know, touch a part really accurately to set the position of the machine. So I just think that's kind of cool. For me, the silicon carbide and aluminum oxide are mainly an appearance thing. Do you want a black shiny ball or do you want a white ball, which I also think looks cool. The stainless, it's just kind of an all-purpose beater. You know, you don't really have to worry about too much. You can't shatter it, so that's one thing. But again, unless you're dropping the top onto some other thing that is super hard, you're not going to break the ball. So if you can avoid that, you're good. I mean, I let my kids play with ruby tops and they never broken one. So I don't think that is a huge concern. What else do you want to know? Alright, this top's starting to go. Well, I guess you guys will be able to keep track of the spin time. I have no idea what it's been, but again, this wasn't a super long spin. Even though it was a pretty decent release, there wasn't a lot of axial wobble. It's pretty much straight up and down and going in a circle, and that's really what you're trying to achieve. Anyway, I think that's about it. What did we cover? We covered contact points, spin surfaces. Oh, I guess the only other thing I want to mention, if you are comparing spin times, it's got to be apples to apples. So some people are like, oh, this top spins so much longer. If it is a bigger top or a heavier top, then yeah, it's going to spin longer because it has more momentum and there's more energy retained. So this is basically a 1-inch diameter top. You know, then whatever the material is, brass and copper are pretty similar. Tungsten, I totally don't remember what the difference in density is, but I think it's at least twice as heavy as brass, which means it can potentially spin a lot longer. It also means you have to put a lot more energy into it to begin with to get up to the same speed. So for me personally, I find the tungsten tops a little bit hard to spin, although for me as well, they do spin longer. So it's pretty easy to get like a 12-minute spin for me out of a tungsten top. I think there's one guy that might even have a YouTube video that spun a tungsten top for something like 19 minutes, which is pretty bonkers and very cool. Alright, I think that pretty much covers it. Questions, comments? Leave them. I'll try to get back to them. Thanks, and we'll see you next time.